Yes, sir.
Okay. So absorption is directly proportional to the concentration. Okay. So this is the basic for both laws. Absorption is directly proportional to the concentration. Absorption is directly proportional to the thickness. Okay. And absorption that is equal to be log of I0 upon I. Okay. That is equal to be molar extinction coefficient, concentration and thickness. Okay. So by using these three equations, we are going to solve some numericals on this concept. Okay. So this first question is here. दिसत आहे? First question is here. Okay. ये example is here. Can you see this? Okay. The molar concentration is 10 to the power minus 3. Okay. Molar solution of compound transmit 20%. How much transmission is there? 20%. Means absorption is 80%. Okay. Of the radiation in a container with path length. Path length means this is the thickness. Is the 1.5 into 10 to the power minus 3. Calculate the molar extinction coefficient. Molar extinction coefficient means you have to calculate the value of epsilon. Molar extinction coefficient. Okay. So their equation is very well known to you. There is the absorption. Okay. Solve kasa करायचं? Absorption is equal to molar extinction coefficient and concentration and thickness. Okay. So you have the value of concentration that is to be the 10 to the power minus 3 means 0.001. Okay. मग concentration आपल्याला माहिती आहे. ओके. थिकनेस पण माहिती आहे, लेंथ माहिती आहे आपल्याला, एक्स व्हॅल्यू आणि ऍब्सॉर्प्शन इथे ट्रान्समिटन्स दिलेलं आहे आपल्याला 20%. म्हणजे ऍब्सॉर्प्शन आपल्याला माहिती होऊ शकते इथनं. मीन्स यू नो अबाउट द ऍब्सॉर्प्शन, देन यू कॅन बी फाइंड आउट द व्हॅल्यू ऑफ molar extinction coefficient. Okay, let's see here Lambert-Beer's law. कसं आपण सॉल्व करू शकतो? देयर इज अ ए मीन्स ऍब्सॉर्प्शन. ऍब्सॉर्प्शन ला कसं दाखवतो आपण? लॉग ऑफ I 0 अपॉन लॉग ऑफ I. ठीक आहे, हा आहे. ठीक आहे. आता इथं लॉग ऑफ I0 म्हणजे कसं आहे? 100%. ठीक आहे, इन्सिडेंट 100%. त्याच्यापैकी काय केले आणि 20% absorb केला. How much absorption is there? 20%. ठीक है. Means what happened? This log of 100 by 20 means log of 5. है ना? Log of काय होईल? 5 होईल. ठीक आहे, झालं absorption झालं त्याचं. ओके, A ची व्हॅल्यू झाली. मग इकडे आपण सॉल्व करू इक्वेशन. इथे बघा कॉन्सन्ट्रेशन दिलेलं आहे 10 to the power minus 3 मोल dm क्यूब आणि थिकनेस दिलेली आहे, एक्स ची व्हॅल्यू दिलेली आहे 1.5 into 10 to the power minus 3. आता हे इक्वेशन आपण असं लिहूया. ठीक आहे. A is equal to किंवा log of I0 upon I is equal to EX and C. हे बघा इथे लिहिलंय. ठीक आहे. आता कुठे कुठे काय येतं? हे अल्फा प्राइम ने सुद्धा दाखवतात आणि किंवा मग इप्सिलॉन ने सुद्धा दाखवतात. ठीक आहे. हे तर आता यूज होण्यावर आहे. बेसिकली हे इप्सिलॉन ने दाखवतात. आता काही बुक्स थोडंसं आपल्याला तिथं डिफरन्स पाहायला मिळेल. तर हा बघा लॉग ऑफ I0 अपॉन I हा जो आलेला आहे हा आहे किती? लॉग ऑफ 5. ओके. हॅलो, आवाज येतोय रे सगळ्यांना? आपण एक दोन प्रॉब्लेम पाहू म्हणजे तुम्हाला कसं सॉल्व्ह करायचं लक्षात येऊन जाईल. ठीक आहे. मग पहा, एप्सिलॉन काढायचं आपल्याला, ही व्हॅल्यू काढायची आहे आणि त्याचं इथे दिलेला सी ची व्हॅल्यू आहे. ठीक आहे. मग पहा पुढे आपण कसं सॉल्व्ह करणार. मोलर एक्सटेन्शन कोएफिशिएंट इज इक्वल टू काय करणार? हे लॉग ऑफ 5 जे आहे इकडे, लॉग ऑफ 5 आणि इकडे काय आहे त्याचं थिकनेस आणि त्याचे कॉन्सन्ट्रेशन म्हणजे सी आणि एक्स हे काय जातील इकडे डिवायडेड होतील याला ए ला. म्हणजे आपल्याला मोलर एक्सटेन्शन कोएफिशिएंट काढता येईल इथे. इथे बघा हा जो सी एक्स आहे हा सी एक्स कुठे जाईल? डिवायडेड बाय ए. इथं सी आणि एक्स. ठीक आहे, मग याला आपण थोडं मॅथमॅटिकली ट्रान्सफर केल्यानंतर हे सगळं सॉल्व्ह केलं तर आपल्याला जे काही उत्तर मिळेल दॅट इज इक्वल टू बी द 0.46. आता हे सगळं कॅल्क्युलेशन करायचे डायरेक्ट आपण कॅल्सी यूज करून सुद्धा सॉल्व्ह करू शकतो. ओके, पण आपण एखाद्या क्वेश्चनला ऑन द बेस ऑफ द लॅम्बर्ट्स अँड बेस लॉ हाऊ टू सॉल्व इट, सो यू हॅव टू अंडरस्टँड एव्हरी टर्म what is given for you, okay, and then convert it as per our requirement, okay, and then put this all value into the given formula and then you can calculate it, okay. But if you given by the transmitter, so then you know that we can be calculate, we can be find out their absorption on the basis of transmittance, okay. म्हणजे ट्रान्समिटन्स जर तुम्हाला माहिती असेल मीन्स यू कॅन फाइंड आउट द ऍब्सॉर्प्शन, है ना. ट्रान्समिटन्स माहिती आहे म्हणजे तुम्ही ऍब्सॉर्प्शन फाइंड आउट करू शकता. ओके, दॅट थिंग यू हॅव टू नो. ओके, and then their mathematical conversion of this formula you also be do it. Okay, then you can be solving this question or problem. Okay, let me move to the next question. Next problem is here. A monochromatic radiation is incident on a solution of 0.05 molar. Means this is the concentration. 0.0 molar is a 0.05 molar is the concentration. Then of an absorbing substance. Okay. Then the intensity of radiation is reduced to 1/4 of the initial value after passing through the 10 centimeter length. 10 centimeter is the thickness. X. Okay. X is a 10 centimeter. आणि इथे काय म्हटलेलं आहे, इंटेन्सिटी ऑफ रेडिएशन इज रिड्यूस 1/4 ऑफ द इनिशियल व्हॅल्यू आफ्टर पासिंग थ्रू द सोल्युशन. ठीक आहे, म्हणजे किती आहे, 1/4 आहे, रिड्यूस झालेली आहे. ठीक आहे, 1/4 नी रिड्यूस झालेली आहे इंटेन्सिटी. देन कॅल्क्युलेट द मोलर एक्सटेन्शन कोएफिशियंट. परत काय म्हटलंय, मोलर एक्सटेन्शन कोएफिशियंट आपल्याला काढायचं आहे. ठीक आहे, मग परत पहा सेम फॉर्म्युला, लॉग ऑफ I0 अपॉन I इज इक्वल टू मोलर एक्सटेन्शन कोएफिशियंट, कॉन्सन्ट्रेशन अँड थिकनेस. ठीक आहे, मग हा फॉर्म्युला दिलाय आपल्याला, लॉग ऑफ I अपॉन I0 ऍब्सॉर्प्शन आहे, मग I अपॉन I0. आता इथे काय म्हटलंय, रिड्यूस. रिड्यूस म्हणजे काय झालं, ट्रान्समिट झालेली आहे ना. एखादी इंटेन्सिटी काय होते, इंटेन्सिटी फॉल ऑन द इंटेन्सिटी ऑफ लाइट फॉल ऑन दी homogeneous medium, okay, whether it is solid or liquid, it fall on that. So what happened, some light is absorbed, intensity is absorbed by the medium, okay, and remaining intensities come out from this mixture or come out from this medium. So this is to be the reduced intensity transmitted light, we can call it transmitted light or reduced intensity of light, reduced radiation, असं आपण वेगवेगळ्या यांनी त्याला म्हणू शकतो. आणि ही किती आहे, 1/4 नी रिड्यूस झालेली आहे. 1/4 म्हणजे काय झालं, 1/4. ओके, म्हणजे किती येतं, 0.25. ओके, 0.25. म्हणून आपण इथे जो ट्रान्समिटन्स बघितलेला आहे. ठीक आहे, ऍब्सॉर्प्शन म्हणजे काय होतं, लॉग ऑफ I0 अपॉन I. ठीक आहे, I0 अपॉन I हे झालं ऍब्सॉर्बन्स. पण ऍब्सॉर्बन्सचा जर रेसिप्रोकल केला तर आपल्याला काय मिळतं, ट्रान्समिटन्स मिळतं, है ना. म्हणजे हेच काय झालं, इन्व्हर्सली प्रोपोर्शनल टू दी ट्रान्समिटन्स. ऍब्सॉर्प्शन कसं आहे, इन्व्हर्सली प्रोपोर्शनल टू दी ट्रान्समिटन्स. जेवढं जास्त ऍब्सॉर्प्शन असेल तेवढं कमी ट्रान्समिटन्स असेल. ओके, म्हणजे ट्रान्समिटन्सला जर आपण राईट डाऊन करायला गेलो तर T इज इक्वल टू काय होईल, I अपॉन I0. I अपॉन I0 होतं. हे ऍब्सॉर्प्शन काय आहे, I0 अपॉन I आहे आणि ट्रान्समिटन्स काय आहे, I अपॉन I0 आहे. ठीक आहे, आणि मग ट्रान्समिटन्स किती रिड्यूस झालेला आहे, 1/4 नी, म्हणजे 1/4 म्हणजे 0.25. इथे आपण पाहू शकतो 0.25 व्हॅल्यू. ओके, गॉट दिस पॉइंट. देन नेक्स्ट आणि हे झालं ट्रान्समिटन्स. मग लॉग ऑफ I0 अपॉन I इथे पहा, I0 किती आहे, 100% होती आणि 1/4 त्याची 1/4 म्हणजे किती होते, 25 आहे ना. 25 एवढं काय झालं, ऍब्सॉर्ब झाले. म्हणजे लॉग ऑफ 100 अपॉन 25 म्हणजे किती होते, लॉग ऑफ 4. है ना, किती होईल लॉग ऑफ 4. हे लॉग ऑफ 4 या साईडला राहील. आपल्याला मोलर एक्सटेन्शन कोएफिशियंट काढायचं आहे, तर या लॉग ऑफ 4 चा डिवायडेड बाय काय करावं लागेल आपल्याला, कॉन्सन्ट्रेशन करावं लागेल आणि त्याची थिकनेस करावी लागेल. म्हणजे काय कॅल्क्युलेट करता येईल आपल्याला, मोलर एक्सटेन्शन कोएफिशियंट. ठीक आहे, याला मोलर एक्सटेन्शन कोएफिशियंट. ठीक आहे, ही व्हॅल्यू कॅल्क्युलेट करता येईल बाय सॉल्विंग दिस. लॉग ऑफ 4 काढायचं आणि डिवायडेड बाय कॉन्सन्ट्रेशन आणि थिकनेस केली तर तुम्हाला मिळेल मोलर एक्सटेन्शन कोएफिशियंट. ठीक आहे, तर अशा पद्धतीने आपण याचे न्यूमेरिकल सॉल्व करू शकतो. आणखी काही न्यूमेरिकल्स आहे बुक मध्ये, ते व्यवस्थित वाचा. काही डिफिकल्टी असेल तर मला विचारा. ओके, नेक्स्ट लॉज ऑफ फोटोकेमिस्ट्री है ना. फोटोकेमिस्ट्रीचे काही लॉज आहेत दिलेले. ठीक आहे, फर्स्ट वन इज हियर Crotthers-Draper law. Okay, Crotthers and Draper's law means when if you think about the photochemistry or photochemical reaction, so this photochemical reaction is occurred because of presence of light. But how this light is interfere, how this light is absorbed, how the molecule is undergoes to the reaction. So about that, regarding this concept, the scientists Crother and Draper proposed the one law that is known as to be the law of photochemistry, or this is the firstly proposed this law, that's why it is called as the first law of photochemistry. Okay, and what is this law? This law is only light that is absorbed can produce photochemical change. Okay, then after absorbing the light, if light is absorbed, then it produces the reaction. This is the first law of photochemistry. म्हणजे एखाद्या मॉलिक्युलने जर लाईट ऍब्सॉर्ब केला तरच तो काय जाईल, फोटोकेमिकल रिएक्शन मध्ये जाईल. अदरवाइज इट डज नॉट शो द फोटोकेमिकल रिएक्शन. सो दिस इज द फर्स्ट statement is given by the Crotthers and Draper about the photochemical reactions. Okay, so only light that is absorbed can produce the photochemical change. Photochemical changes occur on the absorption of light. This is the first law. Okay, then next law is proposed by Stark and Einstein. Stark and Einstein, and this law is stated here: molecule absorb a single quantum of light is becoming excited. Okay, means photochemical reaction is occurred due to absorption of light. How it absorbs light? It light absorb and then it undergoes to be the excitation. Okay, and whether it goes to be excitation, then it shows the further reaction. Okay, so that's why this Stark and Einstein proposed this law about the photochemistry. Is a molecule absorb a single quantum. How much energy absorb? Single quantum. Quantum energy is absorbed, one quantum energy, that is E is equal to h nu. You know that energy of quanta h nu, E is equal to h nu. Okay, this is the energy of quanta. So this amount of energy is absorbed by this molecule, and then this molecule undergoes to be excitation. Okay, and after this excitation, it shows the further reaction. Okay, so this is the second law. It is about the photochemistry. It is proposed by the Stark and Einstein. Okay, so you keep in your mind this energy of quanta, that E is equal to h nu. Here n is added as n for the Avogadro's number. It is constant value. Okay, 6.625 into 10 to the power minus 34. Okay, so this energy, firstly, photochemical reaction occur due to absorption of light, and then molecule is excited because of absorption of light. These are the two laws about the photochemistry. The next one is the quantum yield. Okay, quantum yield is very much important concept in the photochemistry. Quantum yield expresses the efficiency. Okay, that's when you carried out any reaction. So in that reaction, firstly, reactant molecule react. Okay, and it produces it convert into the product. Okay, but how much molecule is undergoes to get the reaction, that decide the yield of this product. Okay, efficiency of this reaction. Okay, how much म्हणजे किती मॉलिक्यूल त्या रिएक्शन मध्ये पार्टिसिपेट करत आहेत, तेवढ्या अमाउंट मध्ये काय होईल, प्रोडक्ट फॉर्मेशन होईल. ओके, हे जे काही रेशिओ आहे, दिस इज कॉल्ड एज टू बी द क्वांटम यील्ड. याला काय क्वांटम यील्ड म्हणतो आपण, किंवा याला एफिशियन्सी सुद्धा आपण म्हणत असतो. ओके, means how much reactant molecule convert into the product. So simply it is called as to be the efficiency. Okay, and this is the ratio. Ratio कशाचा रेशिओ आहे, there is a ratio of number of molecule reacting in given time. Means how much molecule is reacted, this first term, and second is the number of quanta of light is absorbed at the same time. ओके, म्हणजे किती नंबर ऑफ क्वांटा ऍब्सॉर्ब केला आणि किती मॉलिक्यूल काय झाले इंटरॅक्ट झाले, सो दॅट रेशियो इज नोन ॲज द क्वांटम. ओके, so it is very important because if you know the how much molecule undergoes, so you can tell about the efficiency of the reactions. Okay, यालाच आपण काय म्हणतो quantum yield. So this is the phi, this is the psi, and here number of molecule reacting in given time upon number of quanta of light absorbed in the same time. Okay, so this is the mathematical expression for the quantum yield. Okay, but basic term आपल्याला काय समजून घ्यायचं, quantum yield म्हणजे काय, in very simple language, A and B molecule react to each other and it produces the product, that is the C. Okay, let me see here. There is the reaction of A with reaction of B. It gives product as a C. But how much A and B react in this reaction, okay, that decide the product yield. है ना, किती अमाउंट मध्ये C बनत आहे ते कशावर डिपेंड राहणार, how much A and B react to each other. Okay, so that decides the efficiency of the reaction. Okay, so this is the basic concept of the quantum yield. Then next is the how to be determine the quantum yield. Okay, so for the determination of quantum yield, we have to do two things. Okay, in two factor we have to be find out two different terms, and that take the ratio of these two, and you will get the value of the quantum yield. Okay, so first thing is here you have to find out number of mole reacting in this reaction. Okay, when you go to find out the quantum yield of any specific reaction, so in that reaction how much molecule reacted, so you can be calculated. So this is the first step for the quantum yield determination. Okay, and with that you can be find out number of mole if you know the concentration. Okay, concentration of reactant before the reaction and after the reaction, means before the product formation and after the product formation. What is the concentration of reactant? Okay, म्हणजे A react with B, it gives a C is a product. Okay, so what is the concentration of this A and B when it is reactant, and what is the concentration of A and B after the formation of the product? Okay, so you know these two concentration, concentration 1 and concentration 2, and if you take the difference of these two concentration, you will get the exact concentration of how much reactant molecule react. Okay, and if you know the concentration, then you can find out number of mole reacting in this molecule, because concentration is equal to N upon V. Okay, so the basic formula for the concentration, concentration is equal to N is the number of mole. Okay, and second one is the volume. So volume is specific. Okay, and concentration is also determined by this method, and then from these two terms you can find out how much molecule involve and participate in the product formation. So number of molecule reacted you can be find out through this method. Okay, so this is the first step toward the quantum yield determination. Okay, the next is here, next factor we have to be find out number of Einstein absorbed or number of quanta energy absorbed by the reacting molecule. This term you can be find out by using this experimental condition. Okay, so there is a, you can see here, for that we have to be set up in this way. There is one source of light is there, source of light, the lens for the filtration, then monochromators, and for that converting this ordinary light means different wavelength of light into the single wavelength, that is called as to be the monochromator. And then sample is cell is here, it is placed into this thermostat for to the maintaining temperature, and then after some light fall on this sample, some light is absorbed and some light is transmitted. So transmitted light, it will be fall on the detector, and on detector you will get the reading in the form of current, So from this reading, you can find out how much light is transmitted from this sample. Okay, this is very simply set up for the determination of number of Einstein or energy absorbed by the uh, quanta absorbed by the reacting molecule. Okay, so for that we use some source. A different type of source can be available. As a sunlight, you can be used arc lamp, mercury vapors, tungsten lamp. So this different type of light is available. Source of light is there, and from that you can use any light source for the determination of quanta. Okay. The next one is a monochromator. This is the lens from this light is passed is a in a beam form, and then it fall on the monochromator. Means monochromator means it simply the filter. Okay, there is a gelatin or color glass, transparent plate. Okay, prism. Okay, so this type of material can be used for the monochromator. Okay, in case of the spectrophotometer and colorimeter, you know that you use the different monochromator. In case of spectrophotometer, there is given one knob for the particular wavelength. Okay, you can set your knob at particular wavelength, means you provide the specific wavelength of light for the analysis. So you fix the wavelength, that means it convert this light into the monochromatic light, a single wavelength of light. Okay. In case of the colorimeter, you know that there is a different color strip, glass strips there. Okay, on that there is different color. It's coated. Okay, so the different color wavelength it is absorbed by this plate glass strip. Okay, and their complementary color is passed out from that. Okay, so that complementary color has specific wavelength, single wavelength is there. So that's why this ordinary light is converted to different wavelength of light is converted into the single wavelength of light through the monochromator. Okay, so this is to the monochromator. It's simply the filter it used to convert different wavelength of light into the single wavelength of light, that is to be monochromatic light. Okay, so after passing from this monochromator, this light is fall on the sample. Okay, sample. It is there is a sample. It reacting is simply called as a reaction cell also. Okay, I mean there is interaction is occur in between two solution from the sample and this attacking or incident monochromatic light. There is interaction in between two them. Okay, so this reaction cell or the sample holder, simply we can say it. So it is made up by the glass cord with a optical windows, okay, and it is put into the thermostat. Okay, for to the keep the thermal condition constant. Okay, for that it put into the thermostat, and there are optical windows is there. Means somewhat some one window for incoming light, means light monochromatic light come from one window, and from second window the transmitted light go away from this or come out from the sample holder. Okay, so here we know that in case of the spectrophotometer and colorimeter, you use the one cuvette. It is made up by the glass. It is simply called as a sample holder, sample cell. Okay, and in that cuvette you put your sample, and then it goes to the further analysis. Okay, it's very simple. This sample cell is there. Okay, then this light interact with this solution from this sample. There is a solution, something solution is there, or something homogeneous medium is there. So light is interact with this solution. So some light is absorbed, intensity is absorbed, and some light here you can see intensity of light is transmitted from that. है ना, इथे काय होता है, intensity of light इथे बाहेर निघत आहे, and then this transmitted light it fall on the detector. Okay, so there is a photo cell is there in a detector, and detector gives some reading as per the intensity of transmitted light. Okay, so how much light you detect by the detector, intensity of detecting light, and firstly the incident light. So by taking this difference in between to them, you will get the value of the how much light, how much intensity of light is absorbed by the sample. Okay, means you know here about the how much number of Einstein absorbed, how much number of quanta is absorbed by the reacting molecule. Okay, so you know the two terms. One is number of moles reacted here, and here you find out the number of quanta is absorbed by the reacted molecule. Okay, so now you know these two terms. So then you can take the ratio of these two terms and you will get the value of quantum yield. That is the, okay, this is the 5. 5 म्हणायचं त्याला. Next. समजलं का रे? Hello?
Yes, sir.
Okay. So next detector is different type of detector is there. Okay. So intensity of light can be measured by two methods. One is a thermopile. एक thermopile आहे, and second one is a chemical actinometer. Okay. So let me see one by one. So first is a thermopile. आता thermopile काय असतं? Thermopile असते, it is the metal strip. It is metal of the silver and bismuth. Metal strip असते, and that metal strip is coating bind with the moving galvanometer. The moving galvanometer means galvanometer is used to measure the current. Okay. So this metal strip is coated with the lamp black or platinum black, and when light is fall on this metal strip, so the metal strip start to heat. Okay, so temperature is goes on to be increasing. Okay, and due to increasing heat, then heat it convert into the current, and that current it can be measured by the galvanometer. Okay, so in this way, by measuring current, you can be find out how much light is fall on this, how much light is used by the reactant. Means quanta you can be find out from that. Okay, this is the thermopile method. Thermo means temperature. Okay, thermo means temperature. Okay, the light energy is fall on this metal strip, and then light convert into the current. Okay, so this is to be the thermopile condition or thermopile method. Okay, the next one is through this method you can be find out the intensity. Intensity can be measured by using this method. Intensity of light can be measured. Okay, means how much light fall on this strip you can be find out by measuring the current. Okay, so this is the thermopile method. The second one is the chemical actinometer. Chemical actinometer means what happens. Let me see here. There are some metals and there are some molecules. They can be used as a chemical actinometer. Means what happens when we think about the photochemical reaction. So there are some initiation processes there. Okay, so in initiation process, what happens? The light is absorbed by this molecule or atom, and then this molecule or atom undergoes to the excitation. Okay, and extra excitation, that is no mean by it is to be the activated. It goes to be the activated state. Okay, so after the activation of this molecule, after the oxidation activation, it provide their energy or it transfer their energy to the reacting molecules, and then this reacting molecule undergoes to be the further reaction and it produces the product. Okay, we know that in case of the photosynthesis reaction, there is a chlorophyll. Okay, and chlorophyll when interact with the light means it absorb the light from visible region and undergoes to be activation mode. Okay, it excited, and due to the excitation, it transfer their energy to the another CO2 and H2 molecule, and then CO2 and H2 molecule get react to each other and form the glucose molecule plus oxygen. So this is the method and use of the chemical actinometer and role of this chemical actinometer in various reactions, photochemical reactions. Okay. Another example you can be considered here. There is a decomposition of oxalic acid. Decomposition of oxalic acid by using the uranyl sulfate. Okay, so this is the uranyl sulfate is the chemical actinometer. Means what happens? It absorbs some energy. Let me see here. The H nu is the energy. Light energy is absorbed by this uranyl sulfate molecule. There is a molecule. Okay, chlorophyll is also molecule. Then this uranyl sulfate is undergoes to be excitation. Let me see here. There is a star is given on this molecule, means it is the activated molecule. It is a more energetic molecule. Okay. So what happened? It moves from their ground state energy level, means S0, to S1, S2, higher energy level. Okay. And from this energy level, it transfer to the triplet energy level. Okay, due to the internal crossing. And in that level, in a triplet condition, this actinometer transfer their energy to the reacting molecule. Okay, and then reacting molecule undergoes to be the reaction. ओके, म्हणजे काय होतं, हा जो ऍक्टिनोमीटर आहे हा, तो ऍब्सॉर्ब करेल एनर्जी आणि मग एक्साइटेड होईल. एक्साइटेड झाल्यानंतर त्याची एनर्जी खूप हाय राहील आणि हाय एनर्जी झाल्यानंतर हा याच्या जवळची जी एनर्जी आहे ना ऍब्सॉर्ब केलेली, ती एनर्जी हा काय करेल, या ऑक्झॅलिक ऍसिडला देऊन देईल आणि मग ऑक्झॅलिक ऍसिडची एनर्जी हाय झाल्यामुळे ऑक्झॅलिक ऍसिड डिकम्पोज होऊन जाईल. ओके, डिकम्पोज इनटू दी CO, CO2 and H2O, and again we get this uranyl oxide. Okay, so these are the two methods. Okay, here for the determination of intensity of light. First is thermopile, by measuring this uh, by using the galvanometer. Okay, and then this chemical actinometer, it play a vital role in the photochemical reactions. Next, these are the instruments for the quantum yield determination. Quantum yield of some important photochemical reaction. Okay, these are the some given reaction is there. Okay, let me see. There is the NH3 molecule is decomposed into the N2 and hydrogen. Okay, and their quantum yield is 0.2. 0.2. Now the second reaction, HI, HBr, their decomposition, so their value quantum yield is 2. Okay, now again see, this is the SO2 and Cl2, their value is 1. Okay, and again there is the H2S breakdown into H2 and S, their value is 1. Okay, then there is a different quantum yield value for different reaction. Okay, but here you can see there are three different class or three different type of photochemical reactions. Okay, first is there, if the quantum yield is small integer value, small integer 1, 2, 3, up to the 1, 2, 3, like this, small integer. Okay, this is the small integer, so it has some good quantum yield. Okay, it is the also called as the high quantum yield for this reaction. If there is a value is quantum yield is a small integer value. Okay, the second one is a very large, means extremely large quantum yield value. Let me see in the chart. There are given some example. Their quantum yield value is 10 to the power 4 and 10 to the power 6, 10 to the power 3. Okay, so that is to be the very high value of the quantum yield. So this is called as the extremely high quantum yield reaction. Extremely high and खूप जास्त याची काय आहे, क्वांटम यील्ड आहे, अशा टाइपच्या रिएक्शन आहे. Yeah, इथे पाहू शकतो आपण H2 and Cl2, HCl and COCl2 with it gives the COCl. Okay, means first class is there is a small integer quantum yield value. Second one is the extremely large quantum yield value, and then third one is here very small integer value. That means in a fraction of value there, point something value there. So you can see here, you can see in this chart, there is a 0.3, 0.04, 0.1, there is a 0.2. So these are the very small quantum yield reaction. Okay, let me see, these are very small quantum yield reaction is there. Okay, some are small integer quantum yield reaction, then extremely quantum yield reaction, and very small quantum yield reaction. Okay, so photochemical reaction is classified in three classes on the basis of quantum yield. Then reason for the variation of quantum yield. Okay, what happened? there is a variation is occur in the quantum yield. Okay, some are very small quantum yield, there is some are larger and some are extremely large quantum yield. So what is the reason for this variation? So Bonston, it gives two processes for the explaining the reason for the variation of the quantum yield. So these are two processes. First one is a primary process and second one is a secondary process. It is very simple. Let me see. Primary process means what? When any chemical actinometer or any absorbing molecule, it absorb energy and get to be excited. It move to the excited energy level. Okay, like see here, there is a molecule, it absorbs some photon, absorbs some quanta energy, and it undergoes to the excitation. That is to be the A star. Okay, so there is the excitation of molecules occur, activation of molecules occur, initiation of the process is occur. So this is called as to be the primary process. Okay, as we know that in case of the chlorination of methane, in presence of light, chlorination of methane, first upon what happened, the Cl2 molecules break down into radical. Okay, Cl2 molecule by homolytic bond fusion due to the light, it break down into the radical. A radical means it is a highly unstable species, it is activated molecule. Activated species is there. And this activated species then react with the another reacting molecule. So that is known as to be the propagation and termination of the react after the propagation. Termination is there. So these two process, propagation and termination of the reaction is come under the second type is the secondary process. Okay, means if you think about the photochemical reaction, so it occur in a two step. First step is a primary process and second one is a secondary process. In primary process, there is the activation of molecules occur, and in a secondary process, there is a reaction with the activated molecules occur. Okay, and then it goes to the reaction. Okay, but now our time is going to be end, so we have to be stopped here. Okay, if you have any problem, any query, so you can ask me. Hello, 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 hello. I'm audible.